Welcome to our deep dive. If you're starting out in the cloud, you probably know it's more than just spinning up a server, right?
Definitely. There's a whole layer of thinking about how to build things well.
Exactly. How do you build systems that are solid, safe, don't break the bank? Well, today we're kind of getting a cheat sheet. We're looking at how engineers at Google approach this.
Yeah, we're diving into the Google Cloud well-architected framework. It's basically their playbook.
5 key pillars, right? Designed to guide you. It's their thinking, distilled, which is super valuable if you're learning this stuff.
It really is. It shifts your focus from just like individual services to the quality of the whole system, the big picture stuff that makes systems last and scale.
Yeah. Okay, let's jump in. First pillar, operational excellence. What does that actually mean day to day in the cloud?
Fundamentally, it's about making sure everything runs smoothly
Right.
after you deploy it. It's the keeping the lights on part, but done well. The Google engineers talk about principles like ensuring readiness being prepared before launch, knowing how you'll handle incidents if something breaks.
Right, having a plan.
Exactly. And managing your cloud resources efficiently, not letting things sprawl, automating changes where you can to reduce errors, and always looking for ways to get better, that continuous improvement idea.
So, readiness, incident response, managing resources, automation, and always improving. Got it. How does someone actually do that? Like practical first steps?
Good question. Uh, Visibility is huge. You need to see what's happening, maybe using tools like, say, VPC flow logs to watch network traffic.
Okay, see the data flow?
Yeah. And standardization helps a ton. Even simple things like, consistent names for your resources makes life much easier.
Hmm.
Automation is
Yeah.
key. Obviously, you don't have to automate everything right away, but even starting small really pays off.
Incremental steps.
Right. And a big lesson from SRE culture is getting operations involved early, thinking about how you'll run it while you're still designing it.
Not just an afterthought.
Precisely. And these ideas apply just as much to AML systems, too. They need monitoring, smooth operations, the works.
Makes total sense. Operations feels like the foundation. Okay, moving on. Pillar 2. Security, privacy, and compliance. This one feels, well, non-negotiable.
It absolutely is. Bedrock stuff.
Uh-huh.
Google's approach really emphasizes building security in from the very start, security by design, not trying to bolt it on later.
Proactive, not reactive.
Exactly. And a core concept is zero trust. This idea of never trust, always verify. Assume threats could be anywhere, internal or external.
That's a big shift for some folks.
It is. They also push shift left security, finding issues early in your development cycle, not waiting until deployment. Being proactive about cyber defense, using AML securely and using it for security tasks, and of course, meeting all the compliance rules.
Zero trust and shift left, those really change how you approach things, don't they?
Totally. Zero trust changes your network thinking, your identity strategy, you verify everything. Practically, that means strong IAM identity and access management.
Least privileged.
Least privilege, dedicated service accounts, that kind of thing. Encrypting data is crucial, both at rest when it's stored and in transit when it's moving.
Non-negotiable.
Right. Things like network segmentation, maybe using shared VPC, strict firewalls, VPC service controls. They help contain breaches if they happen, and automating security checks in your CI/CD pipeline. That's shift left in action.
And the AML angle.
It's two-sided. First, making sure your AI models and data are secure governance, access controls. Second, using AI itself to improve security, like for advanced threat detection.
Got it. Okay, pillar 3, reliability. Making sure things actually, work consistently.
Precisely. And the key here is defining reliability based on what the user needs, often using SLO's service level objectives.
You're right, setting targets.
Setting realistic targets, yeah. And managing against an error budget. That's a concept from Google's SRE practice that helps balance being reliable with needing to release new features.
A trade-off, managed.
Then there's high availability through redundancy backups, deploying across multiple zones or regions, designing systems to scale horizontally, handle more load, and being able to degrade gracefully if things get overloaded.
So it doesn't just fall over.
Right. And, crucially, detecting failures fast with good monitoring observability and learning from them. Blameless postmortems are huge here. Learning, not blaming.
That cultural aspect. And for ML.
Reliability there also means trust in the data and models, using things like data catalogs, model registries, maybe anomaly detection to catch if a model's performance starts drifting, keeping it trustworthy over time.
Okay. Pillar 4, cost optimization. Always a popular topic.
Yeah. But it's not just about being cheap. It's about aligning what you spend with the actual business value you get.
Smart spending.
Smart spending, fostering cost awareness, optimizing resource usage continuously, always looking for efficiencies.
Practical tips there.
Good capacity planning is fundamental. Don't just guess, look at usage patterns. Using things that scale automatically, like managed instance groups or GKE auto-scaling, is key.
Match resources to demand.
Exactly. And take advantage of discounts. Committed use discounts, sustained use discounts, spot VMs for jobs that can handle interruption. It all adds up.
You need to know the options.
You do. And visibility again. Cost
Yeah.
monitoring tools, dashboards, see where the money's going. Sometimes even doing a cost post-mortem after a project can teach you a lot.
Makes sense. And for AML projects.
Really connecting the cost back to the specific business goals or KPIs. And having reporting focused just on those ML activities.
Right. Final pillar, performance optimization, making things fast and efficient.
Yep, ensuring systems meet performance needs without wasting resources. Principles here involve smart resource allocation, using elasticity again, designing modules like microservices, and always monitoring and tuning performance.
How do you put that into practice?
Well, choosing the right machine types, for instance, not too big, not too small. Using load balancing effectively, maybe flow control, or even load shedding to prevent overload during huge traffic spikes.
Handling the peaks.
Right. Planning capacity based on intent, not just current load. And in complex systems, tracking latency is vital to find those bottlenecks.
And for AML performance.
Often involves lots of experimentation, running frequent tests, maybe in separate environments, to figure out the best model settings or the right infrastructure. It's very iterative.
So that's the 5 pillars: operational excellence, security, reliability, cost, performance. It really does sound like more than just a checklist.
It is. It's a framework, a way of thinking based on, like a lot of real-world experience from Google's engineers. It helps you build systems that are resilient, efficient, secure, the whole package.
A roadmap, really.
Yeah.
So for you listening, as you think about these pillars, ops, security, reliability, cost, performance, which one feels most critical or maybe most challenging for what you're working on right now in the cloud?
Yeah. Something to think about for your own projects.
Definitely something to consider as you continue your cloud journey.